both cylinders. Net hydrostatic pressure at the bottom of left cylinder equals net hydrostatic pressure at the bottom of right cylinder. So, H1D1G equals H2 minus H3, D2G plus H3 D1G, where D2 is unknown only. On solving we get D2, the unknown liquid density. Hello friends. This is our density meter. Actually a liquid density meter. Here two interconnecting measuring cylinders are connected by a pipe. The pipe is fit with a knob to cut off and connect the cylinders. Let's see how is it working. Cylinders. Keeping the knob closed, we added some water in the right-hand cylinder. Now we are opening the knob. This is the water level now. Watch carefully that the level is dropping here, but it is rising in the left one. This is in equilibrium position now. Water level in both the cylinders are same now. Now let's get the reason behind it. It's the hydrostatic pressure in both cylinders have come to equality. As we know, the hydrostatic pressure P equals HdG. So, H1dG equals H2dG, where H1 equals height of water in left cylinder, H2 equals height of water in right cylinder, D equals density of water, G equals gravitational acceleration. Hence, H1 equals H2. That is equal water level in both cylinders, as D and G are common in both cases. Now we are going to measure the density of an unknown liquid, with the help of this instrument, working under the principle of equality of hydrostatic pressure. Here the unknown liquid is kerosene, and the reference liquid is water. Density of water is known at temperature during experiment, let it be D1 and let the unknown density of kerosene be D2. Keeping the knob closed, kerosene is added to the right-hand cylinder. Now we are going to add the reference liquid water into the left-hand cylinder. Unlike first experiment with a single liquid, this time both the liquid levels in both cylinders must be kept same, keeping the knob closed. Both liquid levels are same now. Let's have a close look. Both liquids are same level. Now we are opening the knob. Closely watch the liquid levels in both cylinders are changing. Have a close look. Water has entered into the bottom of right-hand cylinder. Here we get three different levels H1, H2, H3. While H1 equals height of water in left cylinder, H2 equals height reading of kerosene in right, and H3 equals height reading of water in right cylinder. Now, under equilibrium condition of hydrostatic pressure in both cylinders, net hydrostatic pressure at the bottom of left cylinder equals net hydrostatic pressure at the bottom of right cylinder. So, H1D1G equals H2 minus H3, D2G plus H3D1G, where D2 is unknown only. On solving we get D2, the unknown liquid density. Meanwhile, if you like this video then click on the like button, and if you want to stay connected to our work then please subscribe our channel. Point of View 2023. We are about to bring many more to you. Now see, this instrument can not only measure the density of immiscible liquids, but also do the same for miscible one. Here we are going to measure the density of a salt water that we shall produce at one cylinder by dissolving some salt to already taken water in it. Keeping the initial levels of liquid same and closing the knob, we are going to start. Adding salt to water of right-hand cylinder. Stirring well to get an uniform solution concentration. Adding very small amount of food color to detect the liquid levels and the movement of liquid. Now we are opening the knob. Watch the movement of colored salt solution and calculate the density of solution of your own using previous formula. Note that we are measuring an ml unit, but during calculation as the unit cancels out, so only the value of reading becomes meaningful. H3, height of intruded liquid, equals 7 unit. H2, reading of unknown liquid column, equals 55 unit. Have you noticed? The working formula of this instrument is same in both cases. Either water intrudes into unknown liquid column or unknown liquid into water column. The working formula of unknown density remains same. Thanks for watching, and see you in the next videos soon. Till then, enjoy life, enjoy science.